In the early 1960s, astronomers turned their radio telescopes toward the sky and found something that didn't make sense. They detected intense sources of radio waves coming from deep space. When they looked at these coordinates with optical telescopes, they saw what looked like faint blue stars. They called them quasi-stellar radio sources, or for short, quasars. But these were not stars. When we analyzed their light, we realized they were billions of light years away. For a star to be visible from that distance, it would have to be brighter than 1 trillion suns. It was a physical paradox, an object small enough to look like a star, but powerful enough to outshine a galaxy. To understand the scale of a quasar, you have to break your understanding of light. Imagine the skyline of New York City at night. Millions of windows, streetlights, and billboards. Now imagine holding a single flashlight that is brighter than the entire city combined. That is a quasar. A single quasar can emit 1,000 times more energy than the entire Milky Way galaxy. It outshines 100 billion stars working together. And yet, this energy isn't coming from a vast nebula. It is coming from a region of space no larger than our own solar system. How is this possible? What kind of engine fits in a solar system but burns like a galaxy? The answer is the darkest object in the universe. A supermassive black hole. A quasar is not a star. It is a black hole in a feeding frenzy. Most black holes, like the one in our galaxy today, are quiet. They are starving. But a quasar is a black hole that is gorging itself on gas dust and even entire solar systems. It consumes the mass equivalent of hundreds of Earths every single minute. But wait, black holes are defined by their ability to trap light. So why is it glowing? The black hole itself is invisible. What we are seeing is its dinner. This is the accretion disk. Matter cannot fall straight into a black hole. It has to spiral in like water going down a drain. As the gas spirals closer to the event horizon, it speeds up to a significant fraction of the speed of light. The friction between the layers of gas is immense. This friction heats the gas to millions of degrees. It glows with a ferocity that defies imagination, releasing everything from infrared heat to deadly gamma rays. The black hole isn't shining. The graveyard around it is burning. This process makes quasars the most efficient machines in the universe. Consider the sun. It runs on nuclear fusion, smashing hydrogen into helium. This process converts about 0.7% of the mass into pure energy. Gravity is different. When you drop matter into a black hole, the gravitational potential energy released is staggering. A quasar converts up to 40% of the mass into energy. It is nearly 60 times more efficient than a nuclear bomb. It is the ultimate method of extracting energy from matter. For years, these objects were a mystery. Then in 1963, an astronomer named Martin Schmidt cracked the code. He was analyzing the light from a radio source called 3C273. He recognized the pattern of hydrogen, but the lines were in the wrong place. They were shifted massively toward the red end of the spectrum. This was redshift. It meant the object was moving away from us at immense speed, roughly 15% the speed of light. This proved it wasn't a star in our galaxy. It was an ancient monster 2 billion light years away. But a quasar doesn't just glow, it shoots. As the black hole spins, it drags the surrounding magnetic fields with it. This twists the magnetic field lines into a tight coiled funnel at the north and south poles. Some of the superheated gas in the accretion disk gets caught in these magnetic elevators. Instead of falling in, it is launched outward. A narrow beam of particles is fired into deep space at 99.9% the speed of light. These are relativistic jets. They can travel for hundreds of thousands of light years, punching through the galaxy and heating up the intergalactic medium. This leads to a terrifying question of perspective. A quasar looks like a star because it is far away. But what happens if that jet is pointed directly at Earth? We call this object a blazar. It is the same object, but we are looking down the barrel of the gun. Because the particles are moving near light speed, the beam appears significantly brighter. It is like standing on the tracks as a high-speed train approaches with its high beams on. You might be wondering, if these things are so bright, why don't we see one next door? Because quasars belong to the past. The quasar era peaked about 10 billion years ago, when the universe was young and dense. Back then, galaxies were messy. They were full of gas and crashing into each other constantly. There was plenty of food for the black holes. Today, the universe is older, stretched out, and quieter. The feast is over. This reveals the ultimate fate of every quasar. They starve. A quasar is not a permanent state. It is a phase in the life of a galaxy. Once the supermassive black hole eats all the gas in its neighborhood, the light goes out. The monster goes to sleep. It becomes a quiet, supermassive black hole, invisible, lurking in the dark, waiting for its next meal. And this is exactly what lies in the center of our own galaxy. This story isn't just about distant galaxies. It is about us. At the very center of the Milky Way sits a supermassive black hole called Sagittarius A. It contains the mass of 4 million suns. Right now, it is quiet. It is on a strict diet, consuming only wisps of gas. But it wasn't always this way. Millions of years ago, our galactic core was active. Our black hole was a quasar shining like a second sun in the sky. How do we know? Because we found the leftovers. In 2010, the Fermi Space Telescope detected 2 colossal structures extending from the center of our galaxy. They are called the Fermi bubbles. These are 2 globes of high-energy gamma radiation stretching 25,000 light-years above and below the galactic disk. They are the shock waves from a massive eruption. They are the cosmic burp from the last time Sagittarius A had a big meal. This power makes quasars the regulators of the universe. They are galaxy killers. To make new stars, a galaxy needs cold, dense gas. But when a quasar turns on the heat and radiation create a wind that blows millions of miles per hour. This wind pushes the cold gas out of the galaxy entirely. Without gas, star formation stops. The galaxy begins to die. The black hole kills its host galaxy to stop itself from overeating. But if you want to see the true limit of nature, you have to look at TON 619. This is a hyperluminous quasar located 10 billion light-years away. Inside it lies the largest black hole ever found. Sagittarius A is 4 million solar masses. The black hole in TON 618 is 66 billion solar masses. It is hard to visualize. This object is so large that our entire solar system, the Sun, Earth, Pluto, and everything in between, would be a microscopic speck inside its event horizon. It shines brighter than 140 trillion suns. It is the undisputed king of the dark. For decades, these monsters were just math. We couldn't see them. That changed in 2019. The Event Horizon Telescope, a network of dishes spanning the entire Earth, turned its gaze toward the galaxy M87. It captured the first ever image of a black hole. We saw the glowing ring of the accretion disk. We saw the shadow of the event horizon. We finally looked the monster in the eye. It proved that Einstein was right. The shadow was exactly circular, a perfect sphere of darkness carved out of the light. These monsters are destructive, but they are also useful. Astronomers use quasars as flashlights to explore the dark. As their light travels billions of light years to reach Earth, it passes through invisible clouds of intergalactic gas. Each cloud absorbs a specific frequency of light. By reading the barcodes missing from the quasar's light, we can map the skeleton of the universe. But the era of peace we live in is temporary. Our black hole is sleeping because it has no food. That will change. In about 4 billion years, the Milky Way will collide with the Andromeda galaxy. Billions of stars will be thrown into new orbits, and massive clouds of gas will be shoved into the center. This fresh fuel will wake the sleeping giants. Sagittarius A and Andromeda's black hole will ignite. For a brief moment in cosmic time, our sky might light up with the blinding fury of a reborn quasar. When we study these jets, we see something impossible. Sometimes the gas in a quasar jet appears to move faster than the speed of light. We call this superluminal motion. Did they break the laws of physics? Number? It is an optical illusion. Because the jet is moving toward us at nearly light speed, the light from the end of the jet reaches us almost at the same time as the light from the start. This compresses the timeline, making it look like the gas traveled vast distances in impossible time. If you could hear space, the sky would not be silent. To a radio telescope, a quasar is the loudest thing in existence. They scream across the radio spectrum. If we convert that data into sound, it isn't a melody. It is a roar. It is the sound of magnetic fields snapping, gas burning, and matter being torn apart at the atomic level. It is the static hiss of a universe in turmoil. This is the final lesson of the quasar. Every peaceful galaxy you see, including our own, is built around a graveyard. The beautiful spirals and calm stars of the modern universe exist only because the monsters finally went to sleep. They ate, the gas blew out the dust, and shaped the structure of the cosmos with fire. We live in the wreckage of a violent past, and we should be grateful for the silence, because if the monster in the center of our galaxy ever wakes up, the lights go out for the rest of us.